What's going on, everybody? It's Sebastian here, and today I'm going to do a few videos on section 1.3 for the average rate of change. For question 1, we're going to find a simplified form of the difference quotient and complete the following table. So the f of x equation that we're dealing with is 3x squared. So real quick, and you're going to see here the x and the h values that will also be shown on my iPad. So let me share screen on there. Okay, so now that it's showing, let's get to work. So for the difference quotient, if you remember from section R, it has this form. We have f of x plus h minus f of x divided by h. So what we're going to do is we're going to substitute x for x plus h in the x squared, and then subtract by 3x squared over h. So let's break this down one by one. So we'll leave the 3 for now. We'll have x squared plus 2xh plus h squared, then minus 3x squared over h. Alright, so we'll multiply 3 times x squared, which is 3x squared. Then we have 3 times 2xh, so that's 6xh. And then we have plus 3h squared. So when it comes to difference quotient problems, typically what you'll see is once you get to a certain point, all the values that are lacking in an h should be eliminated. So the 3x squared and the negative 3x squared, those cancel. So that means they are gone. And then you have 6xh plus 3h squared over h. We could stop here, but we're not done yet, because one thing that all of these terms have in common is an h. So what we can do to simplify it is factor out the h. So we could strip an h out of there, and that leaves the 6xh into a 6x, then the 3h squared into a 3h, and then that h on the denominator becomes a 1. So therefore, we have 6x plus 3h, or in the problem that I showed, it was the other way around flip, but it doesn't matter. What comes first between the x and the h? It's the same answer regardless, as long as you have the right terms. So from this point on, all you have to do is plug in your x's, which are 5s throughout the board. So then 6 times 5, that equals 30. But for the h's, 3 times 2 equals 6. 3 times 1 equals 3. 3 times 0.1 equals 0.3. And then 3 times 0.001 equals 0.003. And so from this point on, all you have to do is add these values individually to the 30. So 30 plus 6, that equals 36. And then 30 plus 3 equals 33. And then 30 plus 0.3, that's 30.3. And then 30 plus 0.003. Actually, wait a minute. That's one too many zeros. My bad. That's going to be 30.03. And those are going to be the 4 values. Okay, so for number 2, we're going to do the same thing. Find the simplified form of the difference quotient and then complete a table. So our f of x in this case is negative 4x squared. Meanwhile, for the x in h table, for our x's, we have 5's across the board. Then for our h's, they range from 2 to 1 to 0.1 to 0.001. So just like in number 1, the first step is to find the difference quotient. So the dq, that's what we want. So in order to do this, we will substitute the x for x plus h and separate the negative 4 and the square sign. Then we're going to subtract the negative 4x squared. So really we're adding. Then at the bottom, we will have an h. So when we work our way down and we break this down right here, we have an x squared plus 2xh plus h squared, just like in the last problem. Then the adding of the negative 4 becomes a positive 4 over h. Then as we continue along even further, we're going to plug in the 4 into the x squared to get that. Then plug in the negative 4 into the 2xh to get negative 8xh. Then plug in the negative 4 into the h squared to get minus h squared. And that's all going to be over h. And again, what you'll see is that this negative 4x squared and the positive 4x squared are polar opposites at the same absolute values, but one's positive and one's negative. So therefore, those are out of here. After that, we have negative 8x minus, negative 8xh minus 4h squared over h. And again, because all of these have h in common, we are going to strip it. We're going to get it out of here. So then when we strip this h out of the negative 8xh, we're left with negative 8x. Hold on, let me rewrite that to make it neater. Then when we take an h out of negative 4h squared, we're left with negative 4h. And then this h on the denominator, once we get rid of that, that is just a 1. So for the difference quotient, the answer is going to be negative 8x minus 4h. Let me highlight that so it's easier to see. Okay, so the next step is to fill in the table. So again, the x value is constant because this is a limit. So when x approaches 5, so we're going to do negative 8 times 5, that equals negative 40. This is going to be a constant here. But what happens for the negative 4h when we plug in 2? That becomes 8. And when we add these two together, that becomes negative 48. Then what happens if we plug in 1? This becomes a negative 4. So negative 40 minus 4 equals negative 44. What happens if we plug in 0.1? This becomes negative 0.4. So then negative 40 minus 0.4 equals to negative 40.4. Then for negative 4 times 0.001, that is going to become negative 0.04. So then negative 40 minus 0.04 becomes negative 40.04. Now for number 3. The f of x is going to be equal to 10x. The xy table is going to be 7s across the board for x, and for y it'll be 2, 1, 0.1, and 0.01. So we're going to find the difference quotient of 10 over x. This is going to be tricky because we're dealing with a fraction now. So what we're going to do first is replace x with x plus h, then subtract 10 minus x, but there's a twist. All of this is over h. This is where a lot of students get confused and they're not sure what to do from here. Well, if we remember least common denominator, we have to make sure that when we're adding and subtracting fractions that they each have a common denominator. So how can we do that? Well, what we can do is multiply the first fraction by x over x. Then for the second, we can multiply x plus h over x plus h. So that way, now what you're going to see is that both fractions have x times x plus h. So then we have 10 times x minus negative 10 minus 10x minus 10h. And all of this is going to be over x times x plus h. And all of this is going to be over h. So then where do we go from here? Well, actually let me do the work. You'll see where it's at. So we'll do 10x. And first of all, what you're going to notice here is that these two 10x's right here, these are polar opposites. One is positive, one is negative. So therefore, those are gone. So that leaves us with negative 10h over x times x plus h. Then when we divide by h, essentially what we're doing is multiplying by 1 over h. And what you're going to notice here is with the cross multiply, the cross factoring, the negative 10h and the h both have h in common. So we can replace those. So we can factor those out. Then at the end, we'll have a negative 10 over x times x plus h. That is going to be the difference quotient. Now what we're going to do is we are going to plug in the x's and the h's. So for this one's going to be awfully tricky. Okay? So first we're going to do 7 times 7 plus 2, 7 times 7 plus 1, 7 times 7 plus 0.1 because x is 7 throughout the board, and then the h's change from 2 to 1 to 0.1, and so on and so forth. Alright, so 7 plus 2, that equals 9. 7 times 9 equals to 63. 7 plus 1 equals 8. 7 times 8 is 56. Then we have 7 plus 0.1, that equals 7.1. So if we take 7.1 times 7, that equals 49.7. And finally, 7 plus 0.01 equals 7.01. And if we do 7 times 7.01, that equals to 49.01. 49.07. But these are not going to be any of the answers because these are all under 10, negative 10 to be specific. So then we have negative 10 over 63, negative 10 over 56, negative 10 over 49.7, and negative 10 over 49.07. However, in the problem, what they are looking for is 3 decimal places. So to make this simple, once you get to this point, I would go on the TI-84 if you have one, and I'd go to the y equals and put negative 10 over divided by x. And the reason I'm doing this, and also I'd hit I'd second window, and I'd have the independent being x and a dependent being auto, which is the y. So let's say the first x point is 63. So negative 10 divided by 63 is approximately negative 0.159. Then if we plug in 56 into the bottom, you'll see that it is approximately 0.179. And if you plug in 49.7, then it becomes negative 0.201. And last but not least, 49.07, that becomes negative 0.238. If you don't have access to a TI-83 or TI-84 calculator, you can simply divide these individually on paper. I just like doing these in a table because the numerator is constantly negative 10. The last problem I'm going to do for this video will be question number 4. So for question 4, our f of x is equal to negative 2x plus 8. We're going to find the difference quotient, and for this one should be easy. Substitute the x for the x plus h and subtract by the 2x plus 8 and put all of this over x. So negative 2 times x is negative 2x. Negative 2 times h is negative 2h plus 8 minus 2x. And then minus a positive 8, turn that positive into a negative, put it all over h. All of the and the minus the negative 2x. Gotta make that important distinction. So all the values that don't have an h are gone. So the 2x's cancel, the 8's cancel. So therefore all that's left is negative 2h over h. We can factor out the h's, and the difference quotient is negative 2. And so because the difference quotient is negative 2, despite the fact that we do have a table full of 4's for the x component, and then for the h's it's 2, 1, 0.1, and 0.01, because the difference quotient is negative 2 with no variables, therefore no matter what, where we plug it in, we might as well just be 0x and 0h, and it's not going to make a difference because 0 times anything is 0, so therefore across the board the answer should just be negative 2's. That's going to do it for this video. I'll see y'all later.